Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 112 should come up on your screen. You do need a calculator for sure. Get started, please. All right, mu. What'd you get for mu, Maximus? $85.8. All right, how about the variance, Maximus? $154.6. Okay. Pass on for the standard deviation. $12.4. All right, so that leaves us at 98.2. And on the other end, we are at 73.4. That's the norm. We need a Z-score for number 85. Pass them on, Kieran. Brandon Darty. 0.0 what? 6. So negative 0.06 is very close to the mean on the left side of it. Looks about right. And the range, what'd you get for the range? Pass someone. Cool. 35. Okay. So that was number one. Number two, for the sake of time, here's the binomial distribution. Here's the setup. N is 12, X is 6. Probability of success is 26. A failure is 74. Let me zoom in. Once again, 12, 6, 0.26, 0.74. And now I'm right here. So, P of 6 equals 12 factorial over 6 factorial, 6 factorial times 0.26 to the 6th power times 0.74 to the 6th power, because 12 minus 6 is that. Therefore, P to the 6 equals 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial for this one. However, I have another one, so that's 6 times 5 times 4 times 3 times 2 times 1 times 0.26 to the 6 times 0.74 to the 6. Eliminate that. So that gives me P of 6 is, hold on. Let me eliminate something else. What is 6 times 5, guys? 30 times 4? 120? Is that correct? What is 12 times 10? 120, right? So I'm going to cancel those like that. So that's going to leave me 3 times 2 times 1 is 6 on the denominator. 11 times 9 times 8 times 10 is 56. That's 99 times 56. 54. I got 5. 54 and 5, that's 59. 45. I got 4. 45 plus 4, that's 49. 4, 4, 5, 5. What is it? What is it? Let's see, 4, this is 14, yeah? 15? Okay. 5544 times 0.26 to the 6 times 0.74 to the 6. Let's see if I can do the division in my head. P to the 6. Let's see. 6 fits into 55. It fits in there 9 times. Carry 1. That's 2. Carry 2. That's 4. Man, I got this. All right, calculators, calculate. 924 times 0.26 to the 6 times 0.74 to the 6 is approximately... Would you get max? Yeah, 920. Okay. Okay. Help them out. Cole, what'd you get? Come on, guys. I asked you guys to get a calculator. My goodness. 0.044. All right. There it is. So those were the 2 problems. I gave you guys an extra practice on binomial, which is number 2, because today we're moving on. Yay. Thank you, Mr. Q. You're welcome. All right, copy the agenda, please. Warm-up number 112, discrete probability distribution, and 2 problems only today. There it is. Copy the code to access home plate, 8KNEY, 8KNEY, 8KNEY. All right. So, tonight's home plate is 2 problems only. They look like this. Check it out, Cole. Let's go. All right. Get a Cornell note ready, please. I can define and compute discrete probability distribution. We're still in the middle of this. We're almost done. But today we're going to add a couple more things to it just to make it funner. Cool. Let's go. Oh, let's go. We got this. All right. So, by now, we are experts at this. Is that correct? So if I was to ask Maximus to explain classical versus empirical versus subjective, he's got it. However, we are past that. We're independent variables and dependent variables, and then from there we label variables as discrete and continuous, and by now we're experts at that as well. And then we know now what a probability distribution is, right? So tell your neighbor what it is, please, to remind them. What is a probability distribution? All right, what is it? Let's see, let's go with maths. What is a probability distribution? What? No, no passing this one. You got this. What is this? A table where the probability adds up to 1. My goodness. From there, I gave you guys formulas for probability distribution, mean, variance, and standard deviation? Yes. From there we got into binomials. Then I gave you the formula for the probability of binomials. There it is, which is the one we used for the warm-up. Is that correct? From there I said, well, now we need the mean, variance, and standard deviation of binomials. There they are. That's what was on yesterday's pop parte, right? Both of these, that one and that one. You need to know those four formulas for the pop parte that some of you missed. However, Mr. Q, is there anything else other than binomial distributions? Well, binomial is only two. What if we have more answers? Well, that's called what? Multinomial distribution. So on your paper, write multinomial distribution and copy the formula, please. There it is. Let's go. Let's go, Cole. We got this. Let me send that to your screen. All right, did everybody get that formula? Yes? P of x equals n factorial over x sub 1 factorial x sub 2 factorial x sub 3 all the way to x sub k times p sub 1 with x sub 1 exponent, p sub 2 with x sub 2 exponent, dot, 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 to p sub k with x sub k exponents. All right. So, how's that going to work, Mr. Q? And by the way, guys, this is very similar to the one we just used on the warm-up. That's why I gave you guys some practice. So, let's get started. Here we go. Example Q. Don't copy this problem because it's lengthy. I want us to start with n first. So on your problem, write n as I read it out loud. N. All right, let me read it. It says, in a large city, 50% of people choose a movie, 30% choose dinner and a play, and 20% choose shopping as leisure activity. Okay, so they gave us percentages. It says, if a sample of 5 people are randomly selected, find the probability of 3 planning to go to the movie, 1 to go to the play, and 1 to go to the shopping mall. All right, so out of all those numbers, tell your neighbor what n is. What is n? What is n, Aleshka? Here, let me repeat it again. Tell your neighbor what n is, please. Then Aleshka is going to enlighten us. What is n? 5. That is correct. Write that down. Here it is. 5 people. Okay. Next, we want to know our x. Let's see. Find the probability that 3 are planning to go to a movie. Wait a minute, but then it says 1 to a play and 1 to a shopping mall. So therefore now we have how many x's? 3 of them. X sub 1, x sub 2, and x sub 3. X sub 1 is 3, x sub 2 is 1, and x sub 3 is 1. And of course, all of these need its p. P sub 1, p sub 2, and p sub 3. All right, so let's find out what p sub 1 is. So I'm going to box p sub 1 with x sub 1 so I can match it on the problem. Here it goes. P sub 1 is what? 3 are planning to go where? To a movie. And according to the problem, what is the percentage of people going to a movie? 50. That is correct. So we write 0.50. All right, let's go to x sub 2. I'm going to use red for x sub 2. X sub 2 says 1 is planning to go to a play. What is the percentage of people going to a play? 30 to a play. That is correct. So that's 0.30. And last but not least, 1, or X sub 3 is 1, and that person is going where? To the mall. Percentage of people going to the mall to do shopping or whatever is what? 0.20. All right, quick observation. Look up. What do you guys notice all the P's add up to? Everyone? 1. That is correct. Another observation. What do you guys notice that all the X's add up to? Everyone? Or technically it's what? To N. Exactly. When you have more than all these, all of them should add to N. Those are observations that you should know. Okay. So, start with our formula. P of X equals N factorial, which is 5 factorial, over X sub 1 times X sub 2 times X sub 3. So X sub 1 is, I'm going to do that in blue, 3 factorial, which is this one, times, the next one is 1 factorial, and the third one is 1 factorial, times its corresponding P. P sub 1 is what? 0.50. 0.50. And what is the exponent for 0.50, which is X sub 1? That is 3. Times 0.30. And the exponent is 1. Times 0.20 with exponent of 1. All right, so 5 factorial is 5 times 4 times 3 factorial over 3 factorial, and then 1 factorial. 1 factorial is just 1 times 0.50 to the third times 0.30 times 0.20. So P of X is, we get rid of the 3 factorials, that leaves us with 20, which is this, over 1 is still 20, 0.50 to the third, 0.30, 0.20. All right, calculators calculate. We'll wait for Cole to give us that magic number. .15. Therefore, find the probability that 3 are planning to go to the movie, 1 to the play, 1 to the shopping mall. The probability is 15%. 15%. From 1 to 5, I'll come to where you with that. All right. Send me your notes, please. All right, example, mega Q. Let me send this to your screen really quick. N. Let me read it out loud so like that you guys can get it started. It says, small airport coffee shop manager found that the probabilities of a customer that buys 0, 1, 2, or 3 cups of coffee are 0.3, 0.5, 0.15, and 0.05 respectively. What does that mean, Mr. Q, respectively? That in that order, that the number of cups mentioned, the percentages over here are mentioned in decimal form. So the 0 corresponds to that one, the 1 corresponds to that one, the 3 corresponds to that one, and, oh, my bad, the 2 corresponds to that one. And the 3 corresponds to that one. All right, then it says, if 8 customers enter the shop, find the probability that 2 will purchase something other than coffee. So it says here 2 will purchase. Then 4 will purchase. Then 1 will purchase. And 1 will purchase. All right? Tell your neighbor what N is. What is N? All right, good conversation. Amelia, N. H, write that down, very good. Now, instead of 1x, how many x's do we have now? Tell your neighbor, how many x's do we have now? Pass on one, Amelia. Logan. Four. X of 1, x of 2, x of 3, x of 4. All right, so read it, tell your neighbor what those numbers are, and then I'm going to have Maximus enlighten us. I even underlined them for you guys there, just to make sure. All right, Max, go. 2, okay, we got that one. And then? 4, got that one. 1, got that one. And what? 1, that is correct. So 4, 1, 2, 4, 1, 1, okay. And of course we need to match it to its probability percent. P sub 3, P sub 4. All right. So let's see. I'm going to start with blue. 2, which is this one. 2 will what? Purchase something other than coffee. What does that mean? Are they going to drink coffee? No. So let's look over here. Which one is the number for no coffee? 0. And what is its percentage? 0.3. That is correct. Or 0.30. Let's go to the next one. 4 will purchase 1 cup. 1 cup. So let's see. What does 1 cup correspond to? What's its percentage, everyone? 1 cup corresponds to 0.5 or 0.50. 0.50. Next. 1 will purchase 2 cups. So how many percentages for 2 cups? 2 cups corresponds to what? 0.15. And last but not least, we got 1 will purchase 3 cups. And what is that? Maximus, its percentage. 0.05. That is correct. All right. Set up your formula. P of x equals 8 factorial over, we got 2 factorial, which is this one, times 4 factorial, which is this one, times 1 factorial, which is this one, times 1 factorial, which is that one, times, now the percentages, 0.30 to the what? Coal to the 2. Yeah, that is correct. Times 0.50 to the what? Maximus. Times 0.15 to the what? Quirin. To the 1. Times 0.05 to the 1 as well. All right, I set you guys up. Finish it off. Find me the percentage, please. Go. .02 what? Okay, well, let's see what the numbers, let's see, really quick. You should have written 8 factorial would be 8 times 7 times 6 times 5 times 4 factorial. Is that correct? Over 4 factorial. And then 2 factorial is 2 times 1. 1 factorial and 1 factorial is just 1. Times 0.30 squared times 0.50 to the 4th times 0.15 times 0.05. So, we cancel these. That leaves us with 8 times 7 times 6 times 5. 8 times 7 is 56. 6 times 5 is 30. So 56 times 3, that's 168, 11680. Bless you, over 2 times 0.30 squared times 0.50 to the 4th times 0.15 times 0.05. So that is P of X equals 840 times 0.30 squared is 0.09, is that correct? Times 0.50 squared, that's 0.0725. 0.50 to the 4th. Come on, people. You're going to make me use a calculator. 0.50 to the 4th. 0.0625. 0.0625 times 0.15 times 0.05. What is that approximately? 840 times all that. All right, what'd you get, Amelia? .2835, so that's 0.3. Which means what? The percentage is what, people? 3%. All right, send that in, please. From 1 to 5, how come tomorrow you with this? Yeah, 5 fours, 5 fours. Okay, let me send you the home play so you can get started on that. Here you go. For those of you that are following on YouTube, there's a home play on the screen. Put in some work. See you guys next time. Peace.